All right, guys. To remind you, some of you are approaching the end of your temporary 2-week access. Oh, shit. So if you still are not clear how to get full access, it's going to involve money. It's the bottom line. You can come see me, or you can read through your emails. So make sure you get full access, because if you don't get full access, it's going to delete all your stuff. Yeah, they don't play around. Yeah.
So is the bundle for the online book and the MyMathLab is still $107?
That was the one you could order through Pearson Direct, and you actually get a physical book and the ad code for MyMathLab.
So is that
$108, I think it was.
Oh,
I don't think they had a sunset for that during the semester. That'd be kind of evil, you know. I don't think they were going to end that suddenly. They didn't say, so it should still be applicable.
To do that, you have to set it through a different way, right?
Yeah, you're going to do the link and the password and the username and the password.
And those still coincide with our one that we made.
It's not. So it's not MyMathLab. It's Pearson. They're the people that control MyMathLab. They sell codes so you can get into MyMathLab. Yeah. Yes.
Isn't that like the same price as
It's like 103 exactly.
Yeah.
So if you don't want the physical copy of the book, you pay $103 for access into MyMathLab, and you get the ebook. Five more bucks, you get the book, which you can sell back, after next semester, because you use the same book the next semester. Right, you guys with me?
Yep.
So 90, 103, 110 uses the same textbook. That was our first attempt to cut down some costs for students. The next thing we're going to try to do is to make it an open source book, and that's a little ways off. Open source books are like free. You can download PDFs from websites. We haven't found a good one yet, so we're just trying to find something. That's the next stage of our cost-cutting thing. All right. So any questions about any of that? The access code and stuff, MyMathLab? Any questions about those technical things? Yes?
So once again, the good thing will be to buy the book with the code together.
Yeah, I would do that.
Wait, so it's on the not MyMathLab but Pearson.
So again, I sent that link out, and it had a username and a password with it. It was Grossmont and math. And if you log into the Pearson website using that username and password, it's $108 for the book and the code. Several people have done that. Who got it that way? Look around. There you go. Oh, how long did it take to get to you? A day or two? Wow, shit. Oh, okay. Expedited shipping. That sounds like something you'd probably want. All right. So anything else about that? Okay. Anything else about the class in general, or you guys doing okay? I'm glad to see so many of you. That's nice. It's easy in a big class to feel like you can just not come and who cares? Yes? Yeah, every time you log in, it should be giving you a little message. There you go. It depends on when you logged in and did it. It's from that date. Yeah. Okay. All right. So today we're going to get into, like I said yesterday, we're going to get into word problems. Yay. Don't forget, there's one more lab section. You guys have a quiz after this class on Chapter 1. And then starting tomorrow, there's going to be a round of Quiz 2. That's Section 2.1 through 2.3. So it doesn't include percentages. It doesn't include word problems, not yet. All right. Okay. All right, guys. So there's two levels of word problems you typically see in algebra. One of them is like one step away from math. It's like reading an equation in English. So we're just got to go backwards. Sort of like these. How would you write the sum of a number and 9? I like it. That was nice. right? They're not all going to be like that. Don't get excited. A number plus 7. 5 added to a number.
5 plus.
Yeah, you can do 5 plus x or x plus 5 either way. Why does the order not matter on these that I'm doing right now? It's addition. It's addition. So 2 plus 5 is 5 plus 2. It doesn't matter. That's why the less than thing is so evil, because matter, order. That's good, yeah. Order matters. Hey, look at that. That was inadvertently a good example. Order matters with subtraction, right? What's 7 minus 2? 5. What's 2 minus 7? Oh shit, completely different. One is you're making money, the other one is you're losing money, so don't tell me they're the same. They are so not the same. All right. So really the reason they're doing all of these is to show you all the different words that would indicate addition, for example. Sum, plus, added to, more than, increased by. All the ones that would indicate subtraction. Now this one's very, very, very evil. In English, we normally don't say this. This is more of a British thing, to be honest. A number less 5 is x minus 5. We don't normally say that in English, so I try not to use that one too much. They don't even, here we go. Here's the evil one. 3 less than a number is x minus 3. I like it. And that's a fault of English grammar. And for those of you where English is the second language, you're like, yes, English grammar sucks. What's wrong with you people? Sorry, you inherited it. What do you want? The rest of these are exactly the same. What's the difference between 7 and a number? 7 minus x. It's the order in which it comes. The only one where the order changes, because of grammar, is like this one, 3 less than a number. Now, I always get somebody tell me, 3 less than a number, I get this mistake. I get 3 less than x. But how do you read this? Read this for me. That one word, 3 is less than x. That's when it's an inequality. Or, where's the more up here? There. 2 is more than a number. That would be greater than. That would be an inequality. You guys with me? So if I say 3 less than a number, that's subtraction. If I say 3 is less than a number, that's an inequality. Three is less than x. That would be the inequality. I like it. Okay. Of course, this is painful because it is difficult to learn a different language. And that's what math is. It's a different language. Everything that could stand for multiplication. The basic word is product. That's the most primary word we use for multiplication, just like sum and difference for addition and subtraction. But you could also say, like the of. Remember that of means multiply. Times obviously means multiply. Twice, double, triple, all those mean multiply. There's the of again. That means multiply. I like it. So how would you write the product of 5 and the number? 5x, I love it. And if you want to switch it up a little bit, what's twice a number? You could write 2w. Just to, like x is being overused here. Let's use some other letters. Or no, you can always use x if you want to, no worries. I like it. Somebody's like, I don't care, man. Okay. And then division, the main word for that is actually quotient. That's the word that we use the least out of those, and that's why that's the one that everybody forgets. Quotient. Yes, ma'am?
Is twice the number and double the number the same thing?
Yes, I love it.
Okay. Oh, sorry, just wanted to...
So these would both be 2w.
Okay,
I like
I
it.
would
Ruh-roh. So the only way to get w squared is in English it has to say the square of a number or a number squared or a number multiplied by itself. Yeah, so double and twice indicate multiplication by 2. If you had 5 eggs and I had twice that, I would have 10, not 25.
And half of a number?
Yes, so how would you write that one? Good. Read my brain.
Like 1 over x?
No?
Let me see.
Half. 1/2 of a number
Oh, x.
times x. So remember, of means multiply. Okay, I like it. I like it. So it's sort of like if I said you have a $10 bill, and I have 7 of those. 7 of those $10 bills. I have 7 times 10. I have $70. So of means multiply. We normally just use of with fractions and percentages to mean a part of. Right? 20% of means a part of that thing. 1/5 of means a part of that thing. I like it. Is that cool? Or understood anyway? I wouldn't use the word cool though. And then division, hopefully, obviously, ratio. How would you write the ratio of a number and 6? X over 6. I love it. The quotient of 5 and a number. 5 over x. I love it. 3 divided by some number. That kicks ass. 3 over x. I love it. And look at this. 90 miles per every 4 gallons. 90 over 4. I love it. So that per indicates a ratio. Like 80 words per minute. Right? 80 words per 1 minute. I like it. A ratio. Kick ass. So that's just setting up the English and how it translates into math. So let's do a couple of these that involve what we just talked about. Try to set up the equation for this first one here. By the way, in the labs, I have a percentage worksheet, which 2 of the labs have worked on so far. Third one's going to work on it today. And on the other side of that worksheet is the word problems worksheet. And on Wednesday and Thursday, we'll go over the answers to both of those worksheets. Like it. So what would this equation look like? Good. A number divided by 3 equals that number decreased by 10. Love it. And now, how in the world, is everybody cool with that? Just translating it into mathish? And then how would you solve this? What's a good first step? Beautiful. Multiply all the parts by 3. Because I have one part that has division by 3, and that's making it gross. Why am I allowed to do that here? Because Jeff said so, no. What part of this tells me I'm allowed to multiply? No, that's the part that I hope I can multiply so I can get rid of it. Why am I allowed to multiply this thing? Because this thing is an equation. It's got 2 sides. If I make one side 3 times as heavy, and I make the other side 3 times as heavy, they're still freaking equal, right? But if I have 2 fractions that I'm supposed to subtract, I can't just multiply by a number because I want to, because it's divided, and I really would rather it wasn't. Too bad for me. I don't have another side to balance that out. You guys with me? So it's funny. Students get really excited when I show you how to kill fractions. And then they're like, all fractions die. No, you can't. You only have that kind of power in an equation. That's where you're allowed to do something to both sides because it balances back out. So if I do multiply by 3, it would distribute to both of those, right? So here it cancels. Over here I get and then what do I do? What's in the wrong place? Not really. This is where people, now watch. I said this kind of thing before, so this shouldn't freak you too much. Lift your pencils up for a second. Don't write this. Or you don't have to show it to me. Just don't put it on your paper, right? Here is a very common mistake I get. This is how you're evil to yourself. Math by itself is already kind of evil enough. I get this kind of thing. Yay, next. I don't know how I did that either, but I get this all the time. I'm just showing you what I get. You guys see what somebody would, and let me make it a little bit better. How's that? It's still bad. It's still wrong. Do you see what happened? X minus x is supposed to be 0. 3x minus x is 2x. So, I mean, there's nothing wrong with doing this, but you see how you overloaded a side? So, to be honest, what is in the wrong place?
3x.
3x is in the wrong place. It's with the numbers. It's supposed to be over there where the x is, right?
Yeah.
So, x minus 3x is negative 2x. And on this side, I just have so divide by negative 2, x equals positive 15. I like it. I like it. So as long as you show yourself the steps, you should be fine. But it's when people try to do stuff on the side and they try to remember where it goes, that's where it all goes to shit. So don't do that to yourself. Now let's check it. What's 15 divided by 3? 5. And what is 15 decreased by 10? 5. Check. It works. Yay. All right. So try the second one. Sing it. Is this equals. I like it. Cool. So what's the equation look like? So here's my is. That's a good thing to find first.
6x equals 20.
Yeah, so 6 times the number, 6x. 20 less than twice the number. What's twice the number? 2x. And what's 20 less than that? 2x minus 20. The most common mistake is to write 20 minus 2x, but that's not right. If I am 44 years old and you are 20 years less than that, you are not negative 24. You're not waiting to be born. That would really freak me out. You enrolled really early. So this would be twice the number is 2x. 20 less than that would be 2x minus 20. There's that less than being evil. And now this should be a really nice one. There's no fractions, nothing freaky. I like it. The 2x is in the wrong place. 4x equals negative 20. Divide by 4. X is negative 5. I like it. All right. So now we get to the... Now those, please, dear God, the less than, I understand if you make some mistakes on that, but when you make a mistake like that in a real word problem, what do I mean by that? Those first two were just involving numbers. There's no units. Can the answer be negative? All day freaking long. Negative 5 is a number. Great. But if you're telling me you're going to build a shed and it's going to be negative 5 by negative 6 feet, I'm like, what the hell is that shed made of? What is that? You just get too near, you get sucked in. Well, that's a neat shed. Sorry. So please, dear God, don't say, well, math is weird, so the answer could be negative 18 feet. No, it doesn't make any sense. Math isn't that weird. So look at this guy. This is talking about sides of a triangle. We're about to make a big step here. So the first two are one type of word problem. There's one step away from an equation. The next type is a little bit further away from the equation. It's not just reading an equation in English, it's a problem where there's a triangle, or there's people that make so much money compared to each other, or there's so many shoes are being made in this country, and there's more than twice that somewhere else, or whatever. So that's the kind of word problem that people think of when they think word problem. So there are definite steps that if you follow them, it'll be so much easier. If you try to save time, you'll get to the wrong answer faster, sure. Right? So you gotta believe in me that you got it. The first step I'm going to show you, first couple, don't skip them. The mistake I see all the time is something like this. The shortest side of a triangle measures 15 feet less than the longest side. So I see somebody go like even just x minus 15 equals 102. That's some stuff I saw in the problem. Yeah, no, that doesn't make any damn sense. The perimeter should involve doing what? How do you get the perimeter of any shape? Add all the sides. How many sides do I have? 3. So the equation that I set up better have 3 distinct sides in it. Does that make sense?
Yeah.
I like it. So the very first step should be identify what needs math names. What are the English names of the parts involved? How many players are there? It's a freaking triangle, so there are 3 players. What are they using the language of the problem? So the first time you read through a word problem, and I think another problem with word problems is students think you're supposed to read through it once and get the equation. That is insanity, right? The first time I read through a word problem, I don't even think about the math. I just look at the English. What are the names that are used for the 3 sides? First one I see is shortest. Yeah, longest. And then third side. I love it. So first thing I want you to realize is use the same language the problem does. Don't call them side A, side B, side C, because then you don't know which is what. Good Lord. Be nice to yourself. Something else I can do at the same time, I'm going to draw a little picture over here just because I don't have that much room. Whenever you have a geometric problem, you can draw the picture and then I can label it. So I have a visual cue of what the hell's going on. Do you have to draw the picture? No. But if I'm you, I will. Right? So the shortest side is 15 feet less than the longest. The third side is 6 feet shorter than the longest. Which one would I have to know first so I know the other 2? Yeah, if I told you how long the longest was, the other 2 depend on that. So that's the first one I have to give a math name to. And since I don't know how long the longest side is, I'm going to call it X. I love it. So number 1, what are the players? Number 2, what is just X? And those of you who have already had the lab, if you look at the word problem side of that sheet, it tells you the steps that I'm saying right now. And you can draw the picture there in the middle. So the longest side has to be X. Because now if I call the longest side X, what's the shortest side? X minus 15. And what's the third side? 6 feet shorter than the longest side. X minus 6. Kick ass. Beautiful. And then you add all of them. So that's the basis of a word problem. You got a bunch of English. English does not work well with computations. Does that make sense? I need algebraic terms. I know how to add like terms and do all kind of shit. And I know how to do things to both sides of an equation. So I got to take the math names. I take the English relationships and use them to make math names. And then define the perimeter. What I do, like you said, I take these 3 and add them together. So the people that skip this step are the people that do this. Because they see the 15 feet less and they see the 6 feet less. And then they're like, there you go, but what is this missing? Yeah, it's missing this side. That's only 2 sides. So you're never going to get the right answer here. So you're going to add all 3. There's one side, another side, another side. And then another. Like it. And now this should be the easy step. The hard step should be getting to the equation. The easy step should be solving the thing. So what do I got here? 3x minus
Oh, it's minus.
21. Right? They're both negative, so that gets even more negative then. Equals 102.
Add 21.
Yep, add 21. 1, 2, 3. So x is 41. Now if you just circle that and keep going, that's no good. Cool? Because how many answers am I supposed to have? Also, if you say this, so x is 41, right? X is 41. So that's the longest side. What's the shortest side? 41 minus 15. 26. And then the third side, 41 minus 6. 35. And I've made a mistake, but I'm going to see if anybody can point it out to me. Now, I can check it. 67 and 35 is 102, so that checks. What mistake have I made? I don't love you guys. You're like, I don't know what mistake you made. You're the math dude. What are you making mistakes for? Say again? I forgot the units. Please don't make me be a dork. I am a dork, but don't make me be extra dorky. I'm going to write down. You do this. I'm going to say 26 miles, 26 bananas, question mark. And I love it when people make a correction and they use the silly units that I put. There you go, bananas. Jeff. I don't know what that has to do with the problem, but you put it down. No, I was being a dork. You just left the units off. So the units here should be feet. You can even just use fit, fit, fit. Or you can write FT for feet. Have you guys? Sorry. 6 feet, 12 inches. That's the shorthand for feet. That's the shorthand for inches. I'm sure you've seen that somewhere in your life. 11. All right. So any questions on that one there? All right. So let's see what the next one looks like. Do I like it? Shot number 4. My very strong suggestion for number 4 is to draw the picture, even if you normally wouldn't. Another strong suggestion is to put the damn phones away. There you go. Sorry. Just got to lay the law down on it. You can step out the room if you need to conversate in any sort of way. Your time. Are you done? No, I'm joking. No idea what that was. So the most common mistake people make on this kind of problem is they don't label the pictures, so they end up going only halfway. And I always make the joke about if I'm trying to enclose my backyard so my pet pot-bellied pig won't run away, then if you only go halfway, the pig will just go, all right, I'm back, I'm out. You've only done half the yard, what the hell, you can just go out this way. Now, this problem is a little bit evil because they'd have to be very explicit if they wanted you to use the house as a side. So apparently they want us to enclose all 4 sides. Are you with me? I mean, normally if you're going to do your backyard, you need 4 sides. No, you're in the house. You with me? So pretend like he wants fencing by the house also, because the potbelly pig would ruin that side of the house. I don't know, right? They'd have to be really explicit if they meant use the house as a side of the backyard. Okay. What are the players in this problem?
So it's gonna equal to 92.
True. But what are the players? How many players are there? No.
2.
2.
Oh,
The width and the length. Now the perimeter isn't really a player. The perimeter is what the 2 players do together. They make it. You see what I'm saying? So what are the players? The width and length. And what's going to talk about, where's the equation going to come from? What they do together. Together they make the whole perimeter. Which one of those is going to be just X or whatever letter you want to use? Interesting. So we know that the yard is 4 meters longer than it is wide. So which one do you have to know first? How wide it is or how long it is? How wide it is. So I can call the width, let's call it something different than X. Let's call it W. That's crazy. W.
The other one would be L.
No, because, now, real quick, I like it. We don't need 2 variables. In fact, 1 variable is bad enough. We're going to talk about 2 variable problems later. Why would 2 variables suck? Like X plus Y equals 7, there's an infinite number of answers for that shit. No. I don't want that, right? Why do I not need 2 variables? Because the length is related to the width. So they're both built on the same unknown thing. So if the width is W, how long is it?
plus
4. I like that. So the biggest mistake I get, like I said earlier, one mistake I get is this. Don't write that.
No.
Somebody just reads through, doesn't do any of this, and says, 4 longer, that's W plus 4 equals 92. Let me solve that. I'm done, Jeff.
No.
Hell no. The next level mistake I get is this, and at least this I can see some work. But again, what's wrong with this? I only went halfway. I went here and there. I forgot about here and there.
Yeah.
So then I need W plus 4 plus W plus 4. 1, 2, 3, 4 sides. Or of course you could do 2W plus 2W minus 4. Some of you guys know that formula. I wish you didn't know any perimeter formulas because you don't need to know any. Just add all the sides. Area is more complicated. That's why I have all these area formulas. And now it should be the easy step. Now I just have to solve this. I get
4W plus
4W plus 8 equals 92. So we get 4W equals
84.
84. So I get W is
21.
21.
No, you're not done.
Not done yet.
There's nothing up there.
So the width is 21. Let me stop. What's up? Everybody cool with that? I did that a little bit quickly because it's just solving an equation. 1, 2, 3, 4 W's. 4 and 4 is 8. Subtract 8. 84 there. Divide by 4. 21. 21 who? Meters. And then what's the length?
25.
21 plus 4. 25
Meters.
meters. Now real quick. That problem's done. You just circle that. So see how this step helps you set the equation up and it helps you answer the damn thing. So why would you skip something that does all that for you? I don't know. If you get the answer, let me know. The other thing is, here's how I would do this problem. So you don't have to do it this way. Why does that make sense? Because we said W plus 4 is going halfway. So I don't equal it to 92, I equal it to half of 92. Wow, Jeff. You're special. So I'm not doing that. I'm just saying that's valid. If you want to do it that way. Somebody was showing me something earlier that didn't go along with the way I described it in class, but it was beautiful. I told him, That's what math is. You make math your own thing. And then you double check with me to make sure that it's good. Right? I mean, seriously. So math isn't a series of memorizing procedures, even though it feels like it. Math is learning concepts, seeing several ways to apply that concept, and picking the way that makes sense to you. Or making your own freaking way if none of them make sense to you. Just make sure that your way is actually valid. Double check it with me. All right. So if you do this way, you'll get the same answer. Minus 4, 2w equals 42, w equals 21, same answer we got before. Blah, blah, blah. Oh, I like it. Let's try number 5. Might as well just keep going. We got about a little more than 10 minutes left. Oh. You guys out if you don't have that book yet. Now, if you'll notice the picture they drew, this problem is much nicer to you than I would. They gave you the picture and they labeled the damn thing. All you got to do is remember how do the angles in a triangle work. Don't say it. Let's see if people remember. If anybody works construction or anything, at some point in your job, angles come into play. You've got to be careful about the angle. You don't want it to be too extreme in some situations. You don't want to be too shallow in other situations. So, if you forgot, you obviously can't do this problem, but somebody remind me, how do angles in a triangle work, at least in our geometry?
Add up to 180.
They add up to 180. I love it. Why does it make sense? Because a rectangle has 4 angles, and all the angles are 90-degree angles, right? That's 360, and a triangle is cutting that in freaking half. I love it. So all triangles in our geometry add up to be 180. There are other geometries. No. Like on the surface of a balloon or the interior of a balloon, it would add up to different degrees. We're not going to do different geometry, don't worry. So just to show you, this picture is already doing the first couple steps for us. The players are peak, front, and back angles, right? So they already listed the players, peak, front, back. Why does it make sense that the back is X? No? Twice as large as the angle in the back. The front is 20 degrees greater than the angle in the back. They both relate to the back, so I got to know the back side first. This is already done for you in the picture, but showing you why they did it. So if the back side is X, the peak is twice as large. 2X, which is what they have. Good job, people that made this book. And then the front side is 20 greater than that, so X plus 20, which is what they have. Yay. And now if I add all those up, I'm supposed to get
180.
good. For some reason, I always get people equaling that to 0. Really kind of freaks me out. The triangle collapsed. Horrible things happen to the house. So then here you get what now?
4x plus 20
4x plus 20.
equals 180. Subtract 20. Divide by 4.
160, divide by 4. I did that a little quick because That should be easy by this point.
Plug it back in.
So the back side is 40 what? Degrees, kick ass. The front side would then be 40 plus 20. And the peak would be twice 40, 80 degrees. And how do you check it? Yeah, they're supposed to add them to 180, and thank God they did. I like it. What time you got? Let's do one more. See if I can push my luck here. There was a video a while back on YouTube that kind of drove me crazy. There was a guy and this girl driving. He said, if I'm going 80 miles an hour, how far have I gone after an hour?
8 miles.
And she said, no, it won't necessarily be 80. And it just, that kind of thing drives me a little insane. But you should all know this formula. Maybe you don't even know it, what the formula looks like. But you've all applied this formula. If you're going 80 miles an hour and you go for a couple hours, you should know how far you're going to make it. So if you know how far you are from your house, you know how fast you think you're going to go on average, you should be able to figure out how long it's going to take you to get home. And you've used the dirt equation, D equals RT. Dirt, exactly, there you go. Right. So the easiest way to kind of set these problems up, and again, this is not a way you have to do it, but it's the best way to kind of organize what you know and what you don't know, is using a chart. So let's read through this here. Julia, should have just stayed home, Julia, drove for 2 hours on a highway and then 3 hours on a side road. In San Diego, she could be going faster on the side road. Her speed on the highway, in this case, was 25 miles an hour faster than the speed on the side road. She traveled a total of 275 miles. How fast did she travel on the side road? Oh, shit. Do you see how much there's going on in this problem? And this is where people go, I'm just going to skip it. Maybe he won't notice. So what I would do, first off, do you see what the unknown is? They actually just tell you what should be X. Yeah, the side road speed. So side road speed is X. So let's make this little table here. Distance equals rate times time. And you see why there's two rows? Because there's two situations. She was on a highway, so we put highway. And she was on a side road, so we put side road. What does the word rate mean in this case? Speed. Hello. If I'm talking about typing, then it would be how many words per minute I type. It's the rate at which I do something. It's a ratio normally of amount per time. Is what rates very often are. Not always, but very often. So where would I put the X in my chart? Yeah, the side road speed. That's side road speed. Here's X. No. Yeah, so then let's see. What about the highway speed?
Plus 25.
X plus 25. You guys see where that's coming from? And now it sort of becomes every box I kind of want to fill it in. I want to fill in, let's just show you how this works. I want to fill in 4 of the boxes. I'll show you why. So the speed on the highway is X plus 25. It says so right there. What about the time? Julia drove for 2 hours on the highway. That kicks ass. Where does that go?
Time.
So she drove for 2 hours on the highway, 2 hours on the highway. That's a known thing. What about side road? 3 hours. Now here's a big mistake I see. Somebody puts 275 in both of these. That doesn't make any damn sense. Do I know how far she went on the highway versus the side road? All I know is whatever the hell these are, they add up to 275. So this is where my equation is going to come from. It's going to come from this plus this is 275. Stay with me now. If you've never seen this before, you got to get used to it. I haven't used this formula here yet.
Let's see.
Distance equals rate times time. So what do I put here? Well, what's the rate? X plus 25. What's the time? 2. So what's x plus 25 times 2? 2x plus 50. Distance equals rate times time. That's why you only need 2 of the boxes filled in, and the third box you fill in with the formula. Distance equals rate times time. What's going to go here? 3x. Rate times time, 3 times x is 3x. And what are these supposed to do? Add up to be 275. I like it. Either they'll be equal to each other, or they'll add to be something, or they'll subtract to be something. It depends on what it says in the problem. Somebody's really excited to get in here. 2x plus 50 plus 3x. The distances have to add up to be the total of 275. And now it should be the easy step, right? I get 5x, subtract 50. 5x is 225, so x is 45. 45 what? Yeah, miles per hour. And that's all they're asking me for, right? How fast did you travel on the side road? And the side road speed is x. All right. Good Lord. That's plenty. We'll obviously do more of that tomorrow. Yeah. No, it's also for mixture problems. Yeah. So we use that format for other types of problems. You have a lot to kind of catch up on, and we use MyMathLab here for homework in the lab. You follow? So, do you have something happening right now that you have to go to? So, I'm about to meet with one section of lab right now. Yes? All right, that's one you want to do. So, we're going to go over this. I'm going to take a quiz. And while they're working on the quiz, I think you and me are going to be in the front room getting you into MyMathLab setup. So just go over where the Math Study Center is. So it's a room right next to it with all the computers and the... Okay, so go there and wait, I'll be there. 70. 7113 is the room. Yeah, so it's through the library in the tech mall on that side.
Thank you.
Do you want your video paused?
Oh,